All right, today we are going to be talking about Venn diagrams and how we can use them to make probabilities and things like that. So first of all, the notation of a probability of an event, we put a little p before it. So the event is whatever is going to happen. So for an example, this is the probability of A and B occurring. So we're going to go over those symbols and things like that throughout this little lesson. Okay, so I put numbers on here just to give you a concrete example of what I mean when I'm doing these. So as you can see, there's different two circles. Venn diagrams can be as many circles as you want. We have, in this particular case, we have two circles. We have the A circle and the B circle. The A circle here, that's all the elements that occur in event A. So like can ski, and B would be can rollerblade, and those are the number of people that can do that. Out here is the ones that can't rollerblade or ski, and this number right here is the total number of people that were surveyed. So the way that this is, it's just a visual way of representing information. So, and I want to go over the notation with you. So just plain old A here. If we do just A, this represents A. So the number of people that can, let's say, ski is 10, because it's that full circle there. Then we have something here, A and B. The symbol is like a upside down U, and it's also the word intersect, and we use the word intersect there, or and, when to represent, because this spot right here is where they intersect. So it's basically the people that both ski and rollerblade. There's 6 of them out of that 15 total that we have. So that's the and symbol for intersection. Then over here we have or, it's the union, the people that rollerblade or ski. So that would be all of these people. This would be all this people. They rollerblade or they ski. Okay, I'm not the greatest color, especially that quickly. So that would be, I'm going to introduce a formula here. I'm going to introduce a formula. So as you can see, the total for A here, we know right now is 10. The total for B here is 9. If we add those together, because union, when we think of or, we think of adding things together. Unfortunately, that doesn't always work, because if I add the number of people that rollerblade, if I add the number of people that, so the number of people that rollerblade is 10, the people that ski is 9, or however I did it, that's a total of 19 people. However, 6 people are doing both here. 6 people do both. So I subtract the 6 to get that total. Now this is just a formula I'm introducing now. You can just add this one, and this one. Sometimes you don't always get that information. So the formula, if I'm going to write it up here for you, is if you want the or, who roller skates or skis, that the formula is you add all the people that do A, all the people that do B, and then you subtract the ones that do both, because you counted them twice. Okay, basically you counted the 10 here, you counted the 9 here, and those 6 people were counted twice because they both rollerblade and ski. Okay, now if you switch this, if you if you do some algebra here and you add the A and B and you subtract the A or B, we also have a formula for the and. And again, I'm just introducing this formula now because we use it all the time. And you need to see it now, starting now, I guess. So we'll use that today, and you'll see it in a couple of other examples. Okay, not. We represent the not with a C, like a to the c power or a to the comma or God's comma. I'm just kidding. Sorry. Sky comma. And that is anything not in A. So if this is A, this is all the people that are in A, it's everything outside of that. So all of these people. So in this case, this example, it would be 5. 5 people cannot, whatever it is, ski, I said. Not in A and B. So we figure out what A and B is and everything except them. So all this stuff out here. Okay. So that was what? 9. Okay. And then for this one here, not in A or C. So remember, this is A or C. So it's just the 2. But it's everyone that doesn't do either of them. So that would be just 2 people. So you understand the complement. That's what the C stands for here. Why would it be a C? We use the word complement. Or the not. Okay. Oh, sorry. All right, so now some actual examples of creating our own Venn diagrams. So what we have here is we usually draw a box. Okay. And the total number of people. So out of 40 students, so that's our total number of people. 14 are taking English composition and 29 are taking chemistry. So I draw a circle for each. Could do different colors, but I just want to get this done. So these people are the English people. These people are the chemistry people. We're saying that this circle right here should be 14. And this circle right here should be 29. But I don't know how many people are in the and, how many people do both. So I can't actually fill in the little pieces of the circle. Okay? Because, yeah. So what do I have to do? 5 students are taking both classes. So they're telling you 5 people are taking both. So that goes here. So if this full circle here is 14, that means there's 9 people that are just taking English. And because 9 and 5 is 14, because this whole circle here should be 14. So same thing for the 29, making this 24. If I add these both together, these 4 together, or 3 together, I get 38. So that means 2 people aren't doing any. Okay, because you add all these 3 together, I get the people that are taking English or chemistry. So if that's 38 people, that means that 2 aren't. So from that information, I can now answer questions. So there's 2 types of questions. There's how many questions and there's probability questions. How many questions are exactly that? How many? So how many students are taking chemistry? Well, we answered that question already. You gave me that information. That's a dumb question. No, I'm just kidding. What is the probability that a student is taking both classes? So when we're doing probability, we know it's the event goes on top. Both classes, that's 5 people are taking both classes. And so 40 is the denominator. So if I picked one of those 40 people at random, the probability is 5 out of 40 that I would pick a student taking both. You could transfer that to a decimal, but we prefer just to leave it. You can even reduce it, but we don't usually care with this. What is the probability that a student is taking chemistry? So right now we know it was 29. We answered that question already. So it's 29 out of 40. Probability is just taking English composition, meaning they're not taking chemistry. So that how many question is 9. So the how many are doing this divided by the total number of people. So that's probability and Venn diagrams. So we'll talk about this one real quick. All right. In a group of 50 students, 18 take, okay, let's just draw it. So this box is 50 people. 18 take chorus, and 26 are taking band. Excuse me. So this should be chorus, and this should be band. So this number is 18. You can do it however you want. This is just my OCD way. Now 36 are enrolled in chorus or band. So this is how those formulas that I showed you are going to work. So chorus or band, as you know, it's the two circles. When you add the two circles together, you should get 36 students. So if I add the people taking chorus plus the people taking band, so this is the formula, the people taking chorus plus the people taking band minus the people that are taking chorus or band, that's going to give me the chorus and band. Okay, that's going to basically tell me how many people were counted twice. Yeah. It's going to tell me this is telling me how many people are getting counted twice. So if I add these two together here, I get 44. So chorus or band is 44. Well, that's way over the 36 people that are enrolled in all. So I subtract those. So remember, this is band, this is chorus. I added those together. And now I am subtracting the chorus or band. And I get 8. So I know this overlapped here is 8. And now I can fill in the rest of it. This is 10. This is 18. And then down here, if I add all these three together, well, we know we get 36 here, so how many people aren't doing either? That's 14. So I have all my information, and now I can just answer the how many and the probability questions. How many are in both classes? Well, 8. These are how many, so it's not a probability, just a how many. How many are not enrolled in either class? 14. What is the probability that a student takes only chorus? So meaning they're not in this part, they're not taking band, they're only chorus. So that's 10. And since it's probability, I do it over the total. And the probability that a student takes band, so not only band, but they're in band, so that's the original 26, or the full circle, out of 50. Okay. This one... Yeah, okay, this is one, it's a possibility it can happen. I'm going to help you out here. Okay, so this one has 3, those are awesome circles, 3 circles. Those 3 circles are, all of these take a combination. So there's 79 sophomores at school. All of these take some combination of math, geography, and history. So I like to label them. So they're telling you that the total number of who take geography is 41. So it means the geography circle should be 41. History is 36, and math is 30. So the full circle for each of these. So history is 36. Geography is 41, and the full circle for math is 30. I like to do these on the outside there so that I don't have to go searching the question and look through all the words when I have to answer certain questions. So this one, the thing that you have to do is you have to start with, we want to get this number right here, the one where all 3 of them cross, meaning the person takes both math, geography, and history. Or the people, how many people. This little arc here, so let's just change colors so you can see. This little arc here is the people that take math and history. They're in both. This one here, they take geography and history. And then this one here, I guess we go to yellow, would be math and geography. So where they all cross in the middle there, that's where someone that takes all 3. Okay, so this one's a little confusing, but you have to start with the overlaps as best as you can. So people that take math and history is 16. So math and history, that means the purple here is 16. It's a lot of arrows. The number who take geography and history, so geography and history, so that's the green here, that's 6. And there are 8 that take math only. Okay, so starting with the onlys is definitely going to help us a little bit. There are 8 who take math only. If we can fill in any of the little circles, that's great. And 16 who takes history only. Well, that's great. So we really want to get these overlaps, because once you get the overlaps, you kind of get them all. So where do we go from here? So I know that, do I have any other information? 8, 16, geography. Oh, okay. So I know, all right, so I know that this full circle here, the history circle, is 36, yes? Okay, well, I have all the pieces of that. I have the 16 covers this area. I have the 6 that covers the geography and history, and then I have the 16 only. So if I add those up, the 16, the 16, and the 6, I get 38. So what that means is that I have some people that are doing both history and math and geography. Like they're being counted extra times. So I'm going to subtract those, and I get my 2, and I get that 2 that goes here. So I counted all these little parts, the 6, the 16, and the 16, and I should have gotten the 36 that belongs to the full history, but I got extra. So that means that's this piece right here. And then from there, I can do the rest. So if that whole thing is 16, that means this one is 14. If this is 2 and this is 6, this is 4. And then if this one is 6 and that's 41. Oh, yeah, sorry. This is 8, 10, 24. So this here is 6. So 6, 2, and 4 here. That's 12. And then 12 minus 41 is 29. So then I get all my circles filled in. So you can see if you get this middle one, you can get just about all the rest of them. So that was my roundabout way of getting it. You don't have to do a lot of these in general, so don't get too worried about this piece. But now that it's all filled in, we can answer these questions real quick. Okay, I did that. What is the probability that a person is taking math and geography but not history? So math and geography but not history. So here's math and geography. This is math and geography, but we don't want the history one, so that would be 6. There's 6 of them, so total number of people was 79, so that's it. What is the probability that a person takes geography only? So that's this area right here. All the other parts are the overlaps where they do other things. So 29 out of 79. And then over here, what is the probability that a person takes all 3 subjects? Well, we know that 2 is the overlap of all 3, and that's, 2 out of 79. All right, super fun. Have a wonderful day. See you later.